In this video, we'll be studying about the radioactive transformations, that is, changes that occur within a nucleus. We know that the nucleus of a radioactive substance is unstable and it emits radioactive radiations to form a more stable daughter nucleus. The original nucleus is known as the parent nucleus. Now, just like a few seconds ago, I mentioned this term daughter nucleus. This is the answer to that question. The original nucleus, which is being degraded, is known as parent nucleus, and the nucleus that is formed after the radiation emission is known as the daughter nucleus. This process is known as the radioactive transformation. Now, the radioactive substance emits three types of radiations: alpha radiation, beta radiation, and the gamma radiation. Let's talk about them one by one. Emission of alpha particle. When a parent nucleus of a radioactive element with atomic number Z and mass number A emits an alpha particle, the daughter nucleus will have an atomic number Z-2 and mass number A-4. This is our parent nucleus. This is a daughter nucleus. Now, alpha particle is actually equivalent to the helium nucleus. That's why if helium particle is being emitted from this nucleus, hence its mass number will decrease by 4 and atomic number will decrease by 2. One example is the fission of uranium-238. Now, since alpha particle could be written as 2He4, so if we just subtract 2 from 92, we are left with 90. That is the atomic number of thorium. And 238 minus 4 correspond to 234, which is the mass number. Next is the emission of beta particle. During beta decay, a neutron in the radioactive nucleus disintegrates into a proton and an electron. The proton remains within the nucleus while the electron is ejected as the beta particle. So, beta particle is equivalent to the electron. The daughter nucleus formed will have one more proton and one fewer neutron than the parent nucleus. So, mass number remains unchanged, but the atomic number increases by 1. Since atomic number is equal to number of protons and number of proton is increased by 1 because one neutron is being converted into proton in this case, that's why the atomic number increases by 1. So, this is the parent nucleus, the daughter nucleus where atomic number is increased by 1, and this is the emission of beta particle, which is also denoted by this particular representation. For example, fission of 14C6. Now, since the atomic number will increase by 1, hence it becomes 7 and element will change to neutron with the emission of beta particle also represented like this. Lastly, let's talk about the emission of gamma radiations. Gamma emission does not change the mass or the atomic number of the nucleus. Sometimes what happens is that after alpha or beta decay, the daughter nucleus may be in the excited energy state, which is unstable. The nucleus then emits the gamma radiation to move to a more stable ground state. So, this is a reaction. This star indicates the excited nature of this parent nucleus, and after emission of gamma radiation, we achieve the stable nucleus or stable daughter nucleus. For example, degradation or decay of cobalt, where beta particle is being emitted. However, the daughter nucleus is still left in the excited state, denoted by this star. So, this nickel, this excited state of nickel undergoes the gamma decay to form the more stable version of the nickel, and that's how the emission of gamma radiation helps the element to reach a stage which is lesser in energy content. In radioactive decay, either alpha or beta particles are emitted, but not both. A nucleus may continue to decay through multiple stages, emitting alpha or beta particles until a stable nucleus is formed. So that was all about it. I hope this topic is clear to you. Thank you.